Well, how would we go about solving a linear system of equations using matrices? Our steps are as follows. The first thing we're going to have to do is write the augmented matrix. After we write the augmented matrix, we're going to use our row operations to get it in row echelon form. Again, what does echelon form mean? Well, remember that was a main diagonal of ones, zeros underneath the ones, and then the rest of them are just numbers. Any number will do. So this is that echelon form that we were talking about before. Now, after you get it in echelon form, you're going to use substitution to solve for the variables. Our answer here is going to be an ordered triple. That means it's going to be three things within parentheses. So I gave you an example of what that's going to look like here. So here's our system of equations. So step one told us what we're going to do is we're going to go from this system of equations to an augmented matrix. Step 2 says use row operations. So we're going to do all these row operations, right? And that's going to be where a lot of the work comes from. But we want to choose row operations that give us that main diagonal of 1 and zeros underneath. Then step 3 says to use substitution to solve for the variables. So what you need to do is you need to rewrite the matrix into a system of equations. So we're going to change back into a system with variables, substitute, and solve. I also said that our answer was going to be an ordered triple. For example, that's what an ordered triple will look like. So these things are that step 3. Now notice I said we're going to get back into our linear equations with variables and do the substitution. That's why it's called back substitution, because you leave a matrix form and you go into your linear equation form and then you substitute and solve. Well, let's take a look at an example of doing this. So example 4, we want to solve this system of linear equations using a matrix. So the first thing you need to do is get yourself into an augmented matrix. Again, that would be the brackets with the vertical bar closer to the right. Then you got to write the coefficients of all the variables and those answers within this matrix. So I say 3, 1, -1, and 9 for the first equation, then -1, -1, 3, and 3 for that second equation, and 1, 2, -1, and 0. Recall that the goal is to have a main diagonal of ones with zeros underneath them. So what you need to do is you need to just try to figure out what can I do to get the ones there. So your first goal is to get this number to be a 1. Well, if I look here, row 3 already has a 1 in that position, so I can do the row operation of swapping out rows 1 and row 3. So if I swap row 1 and row 3, my matrix becomes 1, 2, -1, 0. Row 2 stays the same as -1, -1, 3, and 3, and row 3 becomes 3, 1, -1, and 9. So what we've done so far is swap 2 rows, but notice now that I've swapped 2 rows, this here is a 1, and I need a 1 in that position. Then I need zeros underneath this 1. Well, let's use row operations to get zeros underneath that 1. If I added row 1 with row 2, won't 1 plus a -1 give me 0? Yeah. So next row operation that I can do is say row 1 plus row 2, and I'm letting you know that's going to be my new row 2. So I'm going to do it on the side over here. If I take row 1, which is 1, 2, -1, and 0, and I add that to row 2, which is -1, -1, 3, and 3, well, I'm going to get 1 plus a -1 is 0, 2 plus a -1 is 1, -1 plus 3 is +2, and 0 plus 3 is 3. So when I write my matrix now, row 1 stayed the same as 1, 2, -1, and 0. My new row 2 is that 0, 1, 2, 3, and row 3 stayed the same as 3, 1, -1, and 9. So I got that to be a 0. Now I need this 3 to be a 0. In order to be a 0, I need to add it with a negative 3. Well, if I were to multiply row 1 by negative 3 and add that to row 3, that number will cancel. So I'm going to multiply row 1 by a negative 3 and add it to row 3. And I'm going to do it over here on the side. If I multiply row 1 by negative 3, I get negative 3, negative 6, positive 3, and 0. Again, I'm going to add that to my row 3 of 3, 1, negative 1, and 9. If I add now, negative 3 plus 3 is 0. Negative 6 plus 1 is negative 5. 3 plus a negative 1 is a positive 2. And finally, 0 plus 9 is 9. So this is my new third row. So let's go ahead and write our matrix. Remember, row 1 did not change. Row 2 did not change. But my row 3 became 0, negative 5, 2, and 9. So we are getting closer to getting this in echelon form. Remember, echelon form, I need a main diagonal of 1s and then 0s underneath all those 1s. So let's see what we have so far. This is a 1 with 0s underneath it. Then the next main diagonal would have a 1 there. Well, I just lucked out that that already has a 1 in row 2 in the second position. But now I need to get a 0 underneath that 1. Well, how would I get a 0 underneath that 1? Well, if I were to multiply row 2 by positive 5 and add it to row 3 as my new row 3, I would get a 0 in that position. So let's do that on the side here. If I multiply row 2 by 5, well, 0 times 5 is 0, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. And then we have row 3, which is 0, negative 5, 2, and 9. If I add these, 0 plus 0 is 0, 5 plus a negative 5 is 0, 10 plus 2 is 12, and 15 plus 9 is 24. So this is my new third row. So I'll write my matrix. And again, you're looking at row 1 not changing. And you're looking at row 2 not changing. But row 3 became 0, 0, 12, and 24. We are almost there. We have a 1 with zeros underneath it, a 1 with a 0 underneath it. The last thing I need to do is get that 12 to be 1. In order to get 12 to be 1, I can divide it by 12. But I don't have division as a row operation, but dividing by 12 is the same as multiplying by 1 over 12. So if I multiply row 3 by 1 over 3, to get a new row 3, I'll have a 1 in that position. So we're looking at row 1 not changing, row 2 not changing, and row 3, well, 1/12 times 0 is 0, 1/12 times 0 is 0, 1/12 times 12 is just 1, and 1/12 times 24 is 2. Again, think of it as dividing by 12 when I multiply by 1/12. So 12 divided by 12 is 1. 24 divided by 12 is 2. Well, now we are in echelon form. We have that main diagonal of 1s and 0s underneath those 1s. So we have gone from step 1 here to step 2. The third thing I need to do is make it back into an equation and solve. So we're doing that back substitution. Okay, well, let's make these back into equations. So if I come here, well, this becomes the coefficient of x, y, z, and this is the answer. X, y, z, answer. X, y, z, answer. So I rewrite this as x plus 2y minus 1z, or just minus z, is equal to 0. The next equation, well, I don't have an x, so I don't need to write it. Then I would write 1y, or just y, plus 2z is equal to 3. And finally, for my last row, I don't have an x and I don't have a y, so I would just write 1z, or just z, is equal to 2. Well, I now need to solve the system knowing this information. Well, I can use substitution to solve the system. If I know what z is, I can plug that information into this equation and find y. So let's start there. So I have y plus 2. Instead of z, I'm going to write what z is. Z happens to be 2, and that's going to equal 3. Well, I can solve this for y. 2 times 2 gives 4. If I subtract 4 from both sides, y is equal to negative 1. So now I have that z is equal to 2 and y is equal to negative 1. The only thing left that I need to solve for is x. Well, I can plug in the information for y and z in the top equation and be able to solve for x. So let's do that. I have x plus 2. Instead of y, I'm going to write what y is equal to, which is negative 1. And then minus z. Instead of z, I'm going to write what z is equal to, and that's going to be 2. And this will equal 0. Well, can I solve for x given this information? I can. Let's just work with this equation. 2 times negative 1 is negative 2, and that's also negative 2 is equal to 0. Combining like terms, x minus 4 is equal to 0. Well, if I add 4 to both sides, I end up with x is equal to 4. So now I know what x is, and what y is, and what z is. So my ordered triple will be in the format of x, comma y, comma z. So I'm going to write what x is, and that's 4, comma, my y is negative 1, comma, my z is 2. So my answer is 4, negative 1, 2, included in parentheses as an ordered triple. Well, let's go ahead and look at the next example. Example 5. Same thing, the very first thing we need to do is write our augmented matrix. Our augmented matrix for this is going to be 2, 1, negative 1, vertical bar, the answer of 10. Second row is negative 1, 2, 2, and 6. Last row is 1, negative 3, 2, and negative 15. Then what I want to do is get it in row echelon form. Well, I need a 1 in this position. Well, if I look here, row 3 already has a 1 in that position, so I can start by interchanging rows 1 and 3. So let's interchange row 1 with row 3. This now becomes 1, negative 3, 2, and negative 15. Row 2 is negative 1, 2, 2, and 6. And row 3 is 2, 1, negative 1, and 10. Next, what I need to do is get zeros underneath that 1. Well, if I add row 1 with row 2, I'm going to get a 0 for row 2. So my next row operation is going to be to add row 1 to row 2, and again that's going to give me a new second row. Well, if I add 1, negative 3, 2, negative 15 to row 2 of negative 1, 2, 2, and 6, 1 plus a negative 1 gives 0. Negative 3 plus 2, negative 1. 2 plus 2 is 4. And negative 15 plus 6 is going to be negative 9. So I end up with, again, my first row didn't change. It stays as 1, negative 3, 2, and negative 15. My second row changed here to 0, negative 1, 4, and negative 9, but the third row didn't change, and I'll leave it as 2, 1, negative 1, and 10. Again, the goal is to get that 2 to be a 0. Well, if I multiply row 1 by a negative 2 and add it to row 3 to give a new row 3, I'm going to get a 0 in that position. So let's multiply row 1 by negative 2. I end up with a negative 2. 3 times negative 2 is positive 6. 2 times negative 2 is a negative 4. And negative 10 times negative 2 is a positive 30. And I'm going to be adding that to 2, 1, negative 1, and 10. If I add, negative 2 plus 2 is 0. 6 plus 1 is 7. Negative 4 plus a negative 1 is negative 5. And finally, 30 plus 10 is 40. My first row didn't change. Our second row didn't change. And here's our new third row. 0, 7, negative 5, and 40. So I have the 1 and the zeros underneath it. The next thing I need to do is get negative 1 to be 1. Well, if I multiply row 2 by a negative 1, that negative 1 will turn into just 1. So the next row operation that we're going to do is multiplying row 2 by a negative 1 to give us a new row 2. Okay, well that means that my first row doesn't change. I write it down. My second row is going to change. Well, 0 times negative 1 stays as 0. Negative 1 times negative 1 becomes positive 1. 4 times negative 1, negative 4. Negative 9 times negative 1, positive 9. Row 3 does not change. So now I have a 1 with zeros underneath it, the next one in the diagonal, and I need 7, that number, to change to 0. Well, what row operation could I use there? I could multiply row 2 by -7 and add it to row 3. So -7 times the second row plus the third row is going to give me a new third row. So let's do that on the side. If I multiply row 2 by -7, 0 times -7 is 0. 1 times -7, -7. 4 times -7, +28. 9 times -7, -63. And adding that to row 3 of 0, 7, -5, and 40. Right, if I add down, 0 plus 0 is 0, -7 plus 7 is 0, 28 plus a -5 gives 23, and -63 plus a +40 gives a -23. So that's my new third row. So if I write my augmented matrix, I now have 1, -3, 2, -15. The first row didn't change. 0, 1, -4, and 9. The second row didn't change. And my new third row is 0, 0, 23, and -23. All that's left now is to get a 1 in this position because everything else has already been obtained. Well, how would I get 23 to be 1? I can divide by 23. Again, that's not part of your row operations, so instead of dividing by 23, we say we're going to multiply row 3 by 1 over 23. And that again is going to become your new row 3. So if we do that, the first row doesn't change. The second row again doesn't change. The last row, 0 times 1 over 23 becomes 0. 0 times 1 over 23 again stays 0. 23 times 1 over 23, again that's like dividing by 23, that gives a +1. And -23 times 1 over 23, again it's like dividing -23 by 23, gives me a -1. I am now in echelon form with my diagonal of 1s and 0s underneath. So I use back substitution to solve. Back substitution says make this back into linear equations and substitute to solve. So I write x minus 3y plus 2z is equal to -15. For my second equation, I don't have an x, but I have y minus 4z is equal to 9. For my last equation, z is equal to -1. Well, do I have enough information to solve? I do. Let's start by finding my y first. So instead of y minus 4 times z, I'm going to replace z with -1, and that's going to equal 9. Well, cleaning up, I get y plus 4 equals 9. If I subtract 4 from both sides, y is going to end up being 5. So far I have that z is -1 and y is 5. All I'm missing is my x. Well, how would I find that x? Plugging it in, I get that x minus 3. Instead of y, I can write 5 plus 2, and instead of z, I can write -1, and that's going to equal -15. So x, 3 times 5 is -15. 2 times a -1 minus 2 is equal to -15. Combining like terms on the left, x minus 17 is equal to -15. If I solve for x by adding 17 to both sides, x is equal to 2. So now I have my x, I have my y, I have my z. So as an ordered triple, my answer would be 2, 5, -1. So my answer is 2, 5, -1. The next video is going to look at special cases of linear systems.